All right, let's talk about black holes. Forget all the crazy sci-fi stuff for a minute. Think of it like this. Imagine you have a really, really heavy bowling ball. If you put it on a trampoline, it makes a big dip, right? Now imagine something so heavy, so incredibly dense, that it doesn't just make a dip. It punches a hole straight through the trampoline. That's kind of what a black hole is. It's an object with so much gravity packed into such a tiny space that it breaks the fabric of space-time itself. It's like the universe's ultimate heavyweight champion. They're usually born when a massive star, way bigger than our sun, runs out of fuel and collapses in on itself. It's a pretty dramatic exit, a huge explosion called a supernova. What's left behind gets squeezed down into an infinitely small point. This point has so much gravitational pull that nothing, not even light, can escape its grasp once it gets too close. That's why they're called black holes, because they literally swallow light, making them invisible. What if a stray black hole, a wanderer drifting through the galaxy, decided to pay our little neighborhood a visit? Imagine a cosmic giant, silent and invisible, making its way towards our solar system. The consequences would be nothing short of biblical, a complete rewrite of everything we know about our home. It's the ultimate doomsday scenario. This isn't some science fiction fantasy either. The galaxy is a busy place. Stars are moving, systems are shifting, and things bump into each other. While it's incredibly, mind-bogglingly unlikely, it's not impossible for a rogue black hole to pass through our celestial backyard. It wouldn't even have to be a big one. Even a small black hole, say one with the mass of our own sun, would be enough to cause complete and utter chaos. It wouldn't need to swallow us to destroy us. Its mere presence would be a wrecking ball swinging through the delicate balance of our solar system. Our solar system is a finely tuned machine, a delicate clockwork of orbits that has been stable for billions of years. The first signs wouldn't be a giant black circle in the sky. Remember, they're invisible. The first clue would be gravity. We'd see things at the edge of our solar system starting to act weird. Comets in the Oort cloud, that giant sphere of icy bodies way out past Pluto, would suddenly get knocked out of their orbits. It would be like a cosmic pool game where an invisible cue ball has just smashed into the rack, sending balls flying everywhere. As the black hole moved closer, past the icy realm of the Oort cloud, it would start to mess with the big players, the planets. The first to feel its influence would be Neptune and Uranus, the ice giants lurking in the outer darkness. Their orbits, which have been predictable for eons, would start to wobble and stretch. They would be pulled towards the intruder, their paths warping like a record left out in the sun. It would be a gravitational dance, but one where the new partner is leading everyone towards a cliff. The black hole's path would determine the exact nature of the chaos. If it passed through the plane of the solar system, it could act like a cosmic slingshot. It might grab a planet like Neptune and fling it out into the cold, empty void of interstellar space, forever to be a rogue planet. Or it could pull it into a new, highly eccentric orbit, maybe one that swings dangerously close to the other planets. The orbits of Saturn and Jupiter, the titans of our solar system, would be next. These two giants are the solar system's protectors. Their immense gravity helps keep stray asteroids and comets away from Earth. But with the black hole's influence, they could become the greatest threat. Their orbits could be destabilized, sending them careening through the system. Jupiter, with its powerful gravity, could be sent on a rampage, flinging the inner planets around like marbles. The cosmic order would be replaced by a terrifying game of pinball. The asteroid belt, that massive collection of rocks between Mars and Jupiter, would become a minefield. Currently, it's held in a relatively stable ring by the competing gravities of the Sun and Jupiter. The black hole's pull would shatter that stability. It would be like kicking an anthill. Swarms of asteroids, from small pebbles to city-sized mountains of rock, would be unleashed. Many would be thrown out of the solar system, but a terrifying number would be sent on a collision course with the inner planets, including our own. Earth would face a bombardment unlike anything in its history. Let's say the black hole gets even closer. It's not just passing by anymore, it's heading straight for one of the gas giants like Jupiter. This is where things get really wild. As Jupiter gets pulled closer to the black hole, it would experience something called tidal forces. It's the same force that causes tides on Earth, but cranked up to an insane level. The side of Jupiter closer to the black hole would be pulled much, much harder than the side farther away. This difference in gravitational pull would start to stretch the planet. This stretching effect has a brilliant, if terrifying, name: spaghettification. It's exactly what it sounds like. The mighty Jupiter, a planet more massive than all the other planets combined, would be stretched out into a long, thin noodle of gas and matter. Its beautiful stripes and great red spot would be distorted and then torn apart. It would look like a piece of cosmic dough being pulled and kneaded by an unseen baker. The planet would literally be unraveled before our eyes, its very substance ripped apart by the black hole's relentless gravity. As Jupiter is being turned into spaghetti, it wouldn't go quietly. The immense friction and pressure from this process would heat the gas to millions of degrees. The unraveling planet would glow brighter than a star, forming a massive, swirling disk of superheated matter around the black hole. This is called an accretion disk. It would be a blazing vortex of light and energy, a final, brilliant scream from the dying planet. From Earth, if we could still see it, it would look like a new, terrifyingly bright star had just ignited in our sky. A funeral pyre for the king of planets. This blast of radiation would wash over the entire solar system, frying the electronics of any spacecraft we have, and stripping away the atmospheres of any planets in its path. Even from millions of miles away, this death cry of a planet would be powerful enough to sterilize the surface of Earth. Now for the question that really matters, what about us? What happens to our little blue marble, Earth? Even if the black hole doesn't come close enough to eat us, its gravitational influence from across the solar system would be, well, catastrophic. The first effect we'd notice would be on our orbit. The delicate balance that gives us our seasons, our stable climate, and our 365-day year would be thrown out the window. Our planet would be caught in a gravitational tug-of-war between the sun and the black hole. Our orbit could become highly elliptical. Imagine a year where, for a few months, we are cooked as we swing incredibly close to the sun, and for the rest of the year we are frozen as we're flung far out into the cold darkness, past the orbit of Mars. The seasons as we know them would be replaced by extreme swings between hellish fire and absolute ice. Then there's the moon, our lovely moon, which controls our tides and stabilizes Earth's axial tilt, would be in mortal danger. Its orbit would be one of the first things to be disrupted. The black hole could easily capture the moon, stealing it away from us and leaving us without our celestial partner. Or even worse, it could send the moon on a collision course with Earth. The impact would be an extinction-level event to end all extinction-level events, a cataclysm that would shatter the crust and vaporize the oceans, ending all life instantly. If the black hole passed close enough, Earth itself could be ejected from the solar system entirely. We'd become a rogue planet, untethered from our sun, hurtling through the black, frozen emptiness of interstellar space. The sky would go dark as we left our star behind. The surface of the planet would freeze solid almost instantly. Any hope for survival would depend on harnessing geothermal energy from the planet's core, living deep underground in a world of total darkness. It would be a cold, lonely, and frankly hopeless existence for whatever was left of humanity. Our sun, the heart of our solar system, the giver of all life and energy, would not be immune. It may be a star, but compared to a black hole, it's just another object to be bullied by gravity. If the black hole wandered into the inner solar system, it would begin a duel with our star. The sun's immense gravity holds the planets in their orbits, but the black hole's gravity would be stronger. It would start to siphon material directly from the sun, pulling streams of hot plasma and gas from the sun's surface. Imagine giant solar flares, bigger than anything we've ever witnessed, being ripped from the sun and pulled across space towards an invisible thief. The sun would look like it was bleeding fire. This material would join the accretion disk around the black hole, that swirling vortex of doom we talked about. This process would make the black hole visible, not as a black circle, but as the brightest object in the sky. A blazing inferno fueled by the stolen lifeblood of our own star. It would be a horrifyingly beautiful spectacle, the sight of our sun being eaten alive. This cosmic theft would have devastating effects on the sun itself. Losing mass so violently would destabilize the delicate balance of fusion happening in its core. The sun could pulsate wildly, its energy output fluctuating dramatically. The star that nurtured life for billions of years would become erratic and violent in its death throes, lashing out at its children as it was consumed. Ultimately, if the black hole was massive enough or passed close enough, there's only one outcome. The sun would be completely devoured. It wouldn't happen in an instant. It would be a process of being torn apart, spaghettified, and swallowed over time. The light of our solar system would flicker and then, finally, go out. The black hole, having consumed its meal, would continue on its journey through the galaxy, a little more massive than before, leaving behind a cold, dark, and lifeless system where our home used to be. It's the ultimate lights-out scenario. So, would this cosmic monster just appear out of nowhere one Tuesday morning? Thankfully, no. We would have some warning. We can't see black holes directly, but we are very good at seeing their effects on the things around them. Astronomers are constantly monitoring the sky. Our first clues would come from the very edges of our solar system, in a region called the Oort cloud. We'd see a wave of gravitational disruption moving through the Oort cloud, like ripples in a pond. Scientists would run the numbers and realize that the only thing that could cause such a massive, coordinated disturbance is a single, massive, and invisible object. The alarm bells would start ringing in every observatory on the planet. As the object got closer, its effects would become more obvious and easier to pinpoint. We would see its gravitational influence on the orbits of the outer planets, like Neptune and Uranus. By measuring these tiny wobbles and deviations from their predicted paths, we could calculate the intruder's mass, trajectory, and speed. We would know exactly where it was going, and when it would arrive. Another way we might spot it is through something called gravitational lensing. A massive object like a black hole bends the fabric of space-time, and this includes bending the path of light. As the black hole passed in front of distant stars or galaxies, their light would be warped and magnified. These strange visual effects would be a dead giveaway that something incredibly massive was passing between us and the distant universe. Knowing it's coming is one thing. Doing something about it is another. Let's be brutally honest here. If a black hole is set to pass through the core of our solar system, our chances of survival on Earth are zero. Absolutely nothing we could do would stop it. We can't blow it up, we can't push it off course. Its gravity is a fundamental force of nature, and we are just specks of dust in its path. Trying to fight a black hole would be like trying to stop a tsunami with a bucket. So, if staying is not an option, what about leaving? Could we pull off a great escape? This is the stuff of science fiction, but it's our only hypothetical shot. We'd need to build massive spacecraft, generation ships or arcs, capable of supporting thousands, maybe millions of people for centuries or even millennia. These ships would have to be completely self-sufficient, with closed-loop life support, ways to grow food, and a stable society. We'd have to launch them away from the black hole's path, sending them out into the void in the hope of one day finding a new home. The challenges would be immense. We're talking about a technological and societal undertaking far beyond anything we've ever attempted. It would be a race against time on a planetary scale. The survivors would be cosmic castaways, their connection to their home planet severed forever. They would carry the memory of Earth, a blue jewel devoured by darkness, as they searched the stars for a new beginning. Thinking about such a terrifying event isn't just about scaring ourselves. It's actually incredibly important. Studying black holes, even from a safe distance, pushes our understanding of the universe to its absolute limits. These bizarre objects are where the laws of physics as we know them, Einstein's theory of general relativity, break down. By trying to understand the extreme gravity, the warped space-time, and the singularity at their heart, we are forced to come up with new ideas and new theories about how everything works. They are nature's ultimate laboratory. They teach us about the life and death of stars and the evolution of galaxies. We now know that supermassive black holes sit at the center of almost every large galaxy, including our own Milky Way. These giants play a crucial role in how galaxies form and grow. They are not just destroyers, they are cosmic architects. By studying them, we learn the story of our own cosmic origins, tracing the history of the universe from the Big Bang to the formation of our own galactic home. On a more philosophical level, considering a threat like a rogue black hole gives us a profound sense of perspective. It reminds us that our home, Earth, is not a fortress. It's a small, fragile world in a vast and sometimes violent cosmos. The stable orbits, the calm sun, the protective atmosphere. We take these for granted, but they are precious and perhaps rare gifts. This realization should encourage us to protect our planet and to work together as a single species, because in the grand scheme of things, we are all in this together, riding the same tiny rock through the immense darkness. So while the thought of a black hole visiting us is the ultimate nightmare, the study of them is a source of wonder and knowledge. They represent the unknown, the power of nature, and the incredible mysteries that still lie hidden in the cosmos. They challenge our brightest minds and inspire us to look up at the night sky and ask the biggest questions. Where did we come from? Where are we going? And what else is out there? Staring into that abyss isn't just about seeing darkness. It's about finding the light of understanding in the most extreme places in the universe.